This is problem 9, 2016 time zone 1, paper 1. A curve is given by the equation y equals sine of the quantity pi cosine x. Find the coordinates of all the points on the curve for which the derivative equals 0, and they have limited us to finding the answers that are between 0 and pi, which is quite typical considering that sine and cosine oscillate, and you tend to have an infinite number of solutions if they don't limit the answer for you. Okay, so I'm going to start with taking the derivative. Okay, so the derivative of sine is cosine. You can find that on your formula sheet if you need to. So it would be cosine of pi cosine x times, chain rule, the derivative of the inside function. So the derivative of that, we would take the constant would just stay. The derivative of cosine is negative sine. And we want to find out where that equals 0. So basically it's already factored for us. We have two things multiplied together to give you 0. This times this. So one or the other of those has to equal 0. Okay, so I'm going to say either negative pi sine x equals 0, put the easy one on this side, or cosine of pi cosine x equals 0. Okay, now this was sort of silly because if these two things are multiplied together to give you 0, either one or the other is 0, and it's not going to be negative pi. So you can divide both sides by negative pi to get rid of it, or you can just say, hey, I know that means sine x has to be 0. So you're taking the inverse sine of both sides of this equation. Okay, so these just undo each other. So basically you're trying to figure out where is sine equal to 0 between 0 and pi. So if you think about your unit circle, between 0 and pi, you're looking for sine is the y value. So you're looking for where do I have a y value of 0, and that is going to be at an angle of 0 and at an angle of pi. So this is the coordinates 1, 0 and negative 1, 0, and so there's your sine. Okay, so this is either going to be 0 or pi. So we have two of our x coordinates already. Now be careful, they said the coordinates of all the points, so I'm going to need an x and a y value for those. I'll hit that up at the end. Okay, on this one, to solve it, I have the cosine of this quantity, so I'm going to need to take the inverse cosine of both sides. So the cosine inverse of this equals the cosine inverse of 0. Okay, so this at least takes care of that. So I have pi cosine x equals the inverse cosine of 0. Now again, I'm trying to figure out where cosine is going to equal 0. And cosine would equal 0 right here. Okay, because that would be the point 0, 1. So it would be at pi over 2. Now it's also here. It's at 0, negative 1. And so cosine does repeat every 2 pi. But it has a solution here, 0 plus 2 pi n, pi over 2 plus 2 pi n, and 3 pi over 2 plus 2 pi n. But you can combine those together to say that every time you go around another pi, you're going to have an angle whose cosine is 0. So in this case, I can combine these two solutions to pi over 2 plus pi n. Now you may wonder, why did I not do plus 2 pi n over here? And that's because this was the end of the solution. Here I've got to take into account this pi. That's going to change things. So here I was going directly to my final answer and could choose these. Really, both of these repeat every 2 pi n, but I can already tell it would be outside of my domain there. But here, this problem is still continuing. Okay, so I have pi cosine x equals pi over 2 plus pi n. So now what I'm going to do is divide through by pi. So then I have cosine of x equals, the pi's cancel, you just have a half plus n. Okay, and so I need to consider this. I could have n are just your integers. So I could have cosine of x equals a half. If I put a 1 in there, cosine x equals 3 halves. Well, cosine can only be between negative 1 and 1. So that won't work. I don't need to go any higher. But if I put n as negative 1, then I would have cosine x equals a half minus 1. So cosine x is negative 1/2, and that could have some solutions for me. Okay, so now it's a matter of where these have solutions. So again, inverse cosine of both sides, or you can go straight to the answer when it's this simple. Okay, so you're trying to think to yourself, where is the angle that has a cosine of 1/2? Okay, and so in the first quadrant, you're thinking, all right, I know I've got pi over 6, pi over 4, pi over 3, but I don't want to be over very much because this is the smallest value I could have. That's this point right here. I'm not over very much, but I'm up pretty high. Okay, whereas this is to the right. I'm over a long way, but not up very high. And this is the one that's easy because everything matches. Okay, and this is your pi over 6, pi over 4, pi over 3. And so I'm looking for the angle whose cosine is 1/2, and that is pi over 3. Now it's also plus 2 pi n. Because I'm at the end of the problem, I don't have to put that because I only want the answers between 0 and pi. Okay, negative 1/2, I've got a little bit of an advantage here because I know it's got to be this corresponding point right here, negative 1/2 square root of 3 over 2. Okay, and so that is 2 pi over 3. And again, plus 2 pi n, but I would be outside of my range. Okay, so I have all my x values now. I have x is 0, x is pi over 3, x is 2 pi over 3, and x is pi. I do have to give the y coordinates, so I just need to substitute that back into the original equation and I'll have it. So the equation, you can still see it there at the top, would have y equals sine of pi cosine 0. Just going to write all these in. Sine of pi cosine pi over 3. Y equals sine pi cosine 2 pi over 3. Y equals sine pi cosine of pi. Okay, so cosine of 0 is 1. So this just becomes sine of pi, which is 0. So this is the point 0, 0. Okay, this next one, you have the cosine of pi over 3. Well, we know that's right here. That's 1/2. So now it's just the sine of pi over 2, which is 1. So this would be the point pi over 3, 1. And then cosine of 2 pi over 3, we had that already too. That was right here. That was negative 1/2. So this becomes sine of negative pi over 2, which would be right here. So that's just negative 1. So this point would be 2 pi over 3, negative 1. Okay, and then we have the cosine of pi. That's right here. Okay, so that's negative 1. So this becomes the sine of negative pi, which is just 0. Okay, so then you have pi comma 0. So these are the 4 coordinates then that would solve this equation.